so happy to be here and see all of you in person. My presentation is not focused on utilization, but it's about a very exciting project in which I took part. It's a REC-CO2 project. And the project, which just ended, was focused on reusing existing wells in CO2 geological storage operations. And I will present briefly today the learnings from this project. So, the full name of the project is Reusing Existing Wells for CO2 Storage Operations. It was an international research project funded through the second Call of Act program, and it involved 6 countries: Netherlands, which led the project, US, France, UK, Norway, and Romania. We had a strong consortium with research organizations, national authorities as associated partners, operators, and a lot of industry. The project caught a lot of attention and a lot of international interest, and during the project 4 new partners joined from industry. The project was started in September 2019 and ended at this summer in August 2022. You can check our website, which has all our public deliverables, and you will see that soon we will publish also our tool that we developed within REC-CO2. So the project started, the idea came from the fact that many hydrocarbon fields approach end of life and are planned for decommissioning. And this all could be potential future CCS sites. And there is potential to reuse existing infrastructure, and we were focused on wells, to upscale CCS and reduce CO2 emissions. There were several reuse alternatives researched, but the main challenge was that all wells have to be assessed. And this assessment is very time-consuming and prone to incompleteness. That's why we have developed within the REC-CO2 project a structured and independent well screening tool and process that will soon be publicly available. So, the main objective of REC-CO2 was to provide decision makers with mechanisms and information to evaluate the reuse potential of existing oil and gas well infrastructure. And our work was divided between 7 work packages, a few on technical issues, and 1 on non-technical issues. The technical work packages were focused on tool development, work package 2, experimental studies, national case studies for well reuse, and of course, best practice recommendations. And the non-technical aspects were related to regulatory environment and social aspects. This is the work package that I have led. So now I will start by presenting the tool, how we developed, and how it was tested and validated. So, we started the development of this tool by reviewing existing standards and reuse cases, and we benefited from a lot of knowledge from the CO2 EOR experience. And after reviewing these standards and reuse cases, we managed to define a suitable storage well, CO2 storage well design. Based on this ideal design, we made the decision trees for several aspects related to the wells, and these were behind this qualitative assessment included in the tool. We focused on 5 pillars when assessing the wells. One is out-of-zone injection, structural integrity, well integrity primary barrier, well integrity secondary barrier, and material compatibility. So you can see on this screen a few screenshots from the tool. The tool is made of 3 parts. The first part is about tool initialization, when you must input the name of the wells and the proposed CO2 structure, and a few information on the storage reservoir. After that, you are invited to complete the well integrity assessment. You can put, I had in the Romanian case like 17 wells, so you can put a lot of wells, but each well will be assessed separately. And these are all tested. This well integrity assessment part of the tool is well tested, validated, improved on the national case studies that we made within RecCO2. And there is another part of the tool which is based on, is focused on cement integrity predictions. This is now a beta feature, but we hope to improve it in the future, maybe in another project. So, you can see how the results are presented at the end of the assessment. There is a color coding based on the severity of expected remediation requirements. So green means that the well can be used in CO2 storage, and no or minor remediation could be expected. But this is all based on the data that you put into the tool. Yellow is a moderate remediation required. Red is severe remediation. And yes, gray means critical information is missing. And it was a lot of gray results in our case studies. But you will see when I come to that. So this tool was validated on the national case studies, and we also presented the tool for testing to regulators and industry. And the feedback was very good because it's a user-friendly tool. Color coding is very useful, and there is a fast assessment of wells. So we can achieve a fast assessment of wells if all the data are available, and if you have the data required in the decision trees. So now I'm going to talk about the case studies that we did in RecCO2. These case studies were very useful for testing, validating, improving, demonstrating the RecCO2 tool. We had 10 case studies from different parts of the world. Many of the case studies, as you can see, were from Europe. So we had at least one case study per the participating country, but we had some case studies also from the industrial partners. The case studies are located both on and offshore, which was very nice. In applications like CCS and CO2 EOR. with depths ranging from 1,400 meters to 500 meters in different reservoir rocks and different reservoir types, with different reservoir capacities reaching up to 280 megatons of CO2. It is very important to mention that only a few instances from the case studies were on projects that are considered for reuse, and many case studies were related to fields that are not proposed for CO2 storage. So there is no investment commitment for those. The key findings from our case studies were that the results from those real reuse studies, projects, the results are in line with the expert assessment. So the tool was validated. It is a very important finding. We managed, by using the tool, to get a systematic approach to screen wells in maybe less than an hour per well. But there was a lot of data missing, and those common data gaps refer to structural integrity, quality of cement sheet, and casing corrosion status. The status, the present status of the wells, it was very hard to assess and find data on that. No, in many cases, like the Romanian case, no recent inspections were made, so we didn't have data on that. My case study, Romania case study, was on an abandoned, depleted gas field, and the abandonment happened in 2000, and the wells were drilled in 1980. So it was very hard to get the data. Although the data was provided by our national authority, but I had a lot of gray results. So I must. So the strong recommendation is to gather new data, because the results of the assessment are very strongly dependent on data availability and quality. The quality of data is another issue, especially when we are talking about old wells. So it is very hard to find. But another important results from our work was that in all cases, significant intervention is required to reuse the wells for CO2 storage. This was very important and a little bit disappointing, but it was expected. Now I will present the regulatory and social aspects considered. This is an activity that I coordinated, and it was a very hard work. Very hard because I'm not a specialist like Ingvild, so it was a very hard work, especially on the regulatory part, very hard. So we started our regulatory framework assessment by collecting all data publicly available on the national legal frameworks for well reuse in CO2 storage. So we collected all this data. We have talked with our national authorities through different workshops that we organized. And based on this collection of data, we made a comparative analysis, and we have highlighted some potential gaps using these scenarios for reuse, because we considered these 4 scenarios. One is no reuse, of course. Second is reuse immediately after end of life or end of hydrocarbon operation. We can reuse the wells after a period of temporary abandonment or hibernation, and we can reuse the wells with enhanced hydrocarbon recoveries. All these scenarios have different regulatory milestones and permitting requirements. So after considering this, we have found that a little specific legislation on well reuse is found in the national regulatory frameworks. There is a large difference between the regulatory regime in Europe and the US, because in Europe you get permits for a storage site, and in US you get permits for injection in wells. A little regulation. So many things are unclear. The major gap is that the transition from hydrocarbon production to storage is not well defined from a regulatory point of view. And we have this problem in Romania, but not only with EOR. We have also problems with the transition from hydrocarbon operation to storage for a depleted field. They are trying to harmonize the petroleum law with the CO2 storage law. They are going to solve that in the near future, I think. They have periodic consultations with industry, so we are hopeful that they will get some good regulations after that. So based on this, all this work on regulatory issues, the data collection, gap analysis, consultations with the regulators and industry, we have produced some recommendations for the improvement of current legislation that were discussed with the regulators through a dedicated workshop. So, as I said, the most problematic part is making the transition from hydrocarbon operation to CO2 storage, and all the regulatory barriers occur mostly when there is a time gap between this hydrocarbon operation and CO2 storage operation, most of them. So in order to fill that gap, it is important to allow postponing the commissioning for wells if a CO2 storage operator is interested to reuse that wells. But most important is that governments encourage assessment of reuse potential prior to decommissioning and support open access to data. This is crucial, but in the same time, we need to get a strategic, they need to have a strategic overview of promising options for storage. Because you can consider using a well if the structure is suitable for storage. You cannot impose to an operator to avoid decommissioning on a well that cannot be used for storage. The social aspects were assessed through a survey, a stakeholder and public survey on well reuse. We have we had a small target for the survey. We had 333 respondents, majority with knowledge on CCS, but we had a first result on the perception on well reuse in CO2 storage from stakeholders, which is very important. This is the first of a kind in our participating countries. And the initial attitude was positive. Based on that, and based on a literature review, we have made some guidelines for future communication strategies. So after all this work, we have produced a best practice guide, the recommendations for well reuse for CO2 storage that are intended to provide industry with recommended means for qualification and repurpose of wells, to assist regulators in understanding the potential for well reuse, and provide foundational knowledge base for well use. I invite you to look at our recommendations on our Rexio2 website. And from all these recommendations, I kept only 3 for you today. The first one is that early consideration of well use at a high level may present sterilization of CO2 storage resources and enable opportunities for use. It is very important to document full well history in order to do the assessment, and it is crucial to enable open data sharing and promote storage potential. Yeah, that's it. Thank you very much.